before we proceed to the problem solving, let's have a idea what is included in this chapter 7, which is the aqueous solutions and the chemical equilibrium, which means ito yung sinasabi natin na it's allow na ang chemical reactions can take place at a constant rate. So kapag wala ang chemical equilibrium, ang rate of reaction na is mag-iiba. Then mahirap makaproduce ng product consistently, which is ang aim nito ay maobserbahan ang epekto ng mga charges in concentration ng isang product. So it is part ang reactant on the fusations ng equilibrium ng given chemical reactions. So let's proceed to the example 7.6, which is what is the Kb for the following equilibrium ng Cn negative plus H2O equals to HCN plus OH negative. So ang solution is that ang appendix ng 3 lots of Ka value na merong 6.2 times 10 negative 10 para sa HCN, so that ang Kv equals to Kw over Ka is equal to HCN times the OH negative over divide the Cn negative. So yan ang ating magagamit. So dahil yan ang tinatawag na Kb expressions for the conjugate base of hydrocyanuric acid, or ang equilibrium expressions for the weak bases uses Kb. So, since may mga value na, isa-substitute lang natin sa given equation. So, ang Kb equals to Kw divided by the Ke equals to HCN then OH negative over or divided by the Cn negative. So, ang value ng Kw is nakadepende siya to the temperatures ng variation na makikita sa table 7.3. So meaning constant ang Kw, which is have the 1.01 times 10 negative 14, which is 25 degrees Celsius. So ang Ke naman ay may value na 6.2 times 10 negative 10. So ang mangyayari, divide lang ang value ng Ke at ang Kw, which is ang Kw is 1.00 times 10 negative 14 divided by the 6.2 times 10 negative 10. So, equals to 1.61 times 10 negative 5. So, yan na ang value ng ating Kb. So, let's proceed to the chapter 13, which is the complex and acid base. So, magkakaroon muna tayo ng idea regarding to this chapter, which is dito ang solutions is made up siya ng dalawang acids or two bases of the different strength, which is ang experimental technique is para maka-acquire ng informations about sa solutions that containing an acid or base, which is alam natin na connected ito sa living things like most yung mga enzymes na can do their job only at this certain level of acidity. Saka ang acids at bases, meron siyang have to maintain the proper pH for the enzymes to work. So let's proceed to the example 13.6, which is to calculate the hydronium ion concentrations of a 1.00 times 10 negative 3 Na2HPO4 solution. So dito sa example 13.16, ang 13 dissociations constant ay ang Ka2 and the Ka3, which is both contain ng HPO4 negative 2. So their value are ang Ka2 is 6.32 times 10 negative 8 at ang Ka3 is 4.5 times 10 negative 13. So ang term na CNAHA or ng the Ka2 is meron siyang value na 1.00 times 10 negative 3 and 6.36 times 10 negative 8. So meaning much larger than siya sa 1. So it can now simplify the denominator. So ang Ka3CNAH is equals to 4.5 times 10 negative 13 times the 1.00 times 10 negative 3 is comparable siya sa Kw. So, ang equation na magagamit is ang open and close parenthesis na H3O positive equals to square root of Ke3 CnAHA at Kw over the CnAHA ng Ka2. So, isa-substitute lang the given value sa equation, which is ang Ka3 is 4.5 times 10 negative 13 times the CnAHA, which is 1.00 times 10 negative 13, plus ang Kw na constant, which is 1.00 times 10 negative 14. At the same time, ita-times yung sa denominator, which is the 1.00 times 10 negative 3 times the 6.32 times 10 negative 8. So, nung na-times is, pwede mo nang ma-divide yung numerator and denominator doon sa times natin na dalawa. After that, you can now use the square root in order to find the answer. So, kapag ni-square root mo na, lalabas ang sagot na 8.1 times 10 negative 10m. So, yan na yung sagot sa example number 2 natin. So, let's proceed to the chapter 12, which is the principles of the neutralizations titrations. So, before we proceed to the problem solving, let's have the idea what is included to the chapters. So, according to these chapters, meaning dito, ginagamit ito para ma-determine ang amount of acids and the bases. Pero nakadepende sa chemical reactions of the analyte with the standard reagent na ang main focus is also yung types of standard solutions at ang chemical indicators na magagamit for neutralization titrations, at ang aim nito is to reinforce the idea that the pH changes steadily over the pH range as an acid. So, okay, let's proceed to the problem solving. The example sa chapter 12, which is a 0.7121 gram samples of wet flour was analyzed by the K-Digital method. The ammonia formed by the additions of concentrated base after digestion with H2SO4 was distilled into 25.00 ml of 0.4977 mHCl. The excess HCl was then titrated with 3.97 ml of 0.04 4012 NaOH. So we should to calculate the percent protein in the wheat and the flour using the 5.70 factor for cereal. So, ang mangyayari, ang amount HCl is equals to 25.00 ml HCl times sa 0.04977. So, in order para maiwan lang yung mole, kailangan natin i-divide yung ml HCl. So, kapag ni-divide, you should to cancel out. Then, kapag ni-times, meron tayong 1.2443 mole. Another is yung amount ng NaOH, which is the 3.97 ml NaOH times the 0.0412. So, in order para maiwan na naman yung mole, kailangan nating mag-cancel out again yung ml NaOH na nakadivide dyan sa mole para mole lang ang maiwan. So, kapag ni-times natin, magkakaroon tayo ng 0.1593 mole. So, ngayon, yung amount ng N, ng amount ng HCl, amount ng NaOH, is yung kanina na ni-times natin yung dalawa. So, kung ano yung result doon is ima-minus natin. So, negative 0.1593 minus the 1.2443 mole. So, kapag ni-minus natin yan, meron tayong 1.0850 mole. So, yung percent ng N equals to 1.0850 mole and times to 0.01407 gram and divided by the mole, and so magka-cancel out tayo dyan. Tapos, huwag natin kakalimutan na i-divide siya doon sa given na sample natin ng wheat flour, which is 0.7121 G sample. After that, we should do times 8 in 100%. So, after that, makukuha na natin yung sagot na 2.1342. So, ang mangyayari dyan, yung percent ng 14 equals to 2.1342% N. So, ita-times natin siya doon sa given ng 5.70 factor for cereal, yung percent ng 14. So, Para ang maiwan lang doon is yung protein, kailangan natin i-divide siya doon sa percent n, which is para ma-cancel out natin yung doon sa 2.13442% n. So magka-cancel out tayo. So mangyayari kapag ni-times na natin, lalabas na yung sagot na 12.16. So yan nga yung percent ng ating protein in the flour using doon sa 5.70 factor for cereal. That would be our discussion for today. Thank you for listening and good day.